Welcome and thank you for standing by. Today's call will now begin. All lines have been placed on a listen-only mode until the question-and-answer session. At that time, if you would like to ask a question, you would press star 1 and record your name when prompted. If you need to withdraw your question, you would press star 2. Today's call is also being recorded. If there are any objections, you may disconnect. And I will now turn the call over to Gray Hautaloma. Thank you. You may begin.
Thank you. Hello and welcome to our pre-launch media briefing for the James Webb Space Telescope. I am Gray Hautaloma with the NASA Headquarters Office of Communications. The Webb team completed the mission's launch readiness review earlier today, and we're going to give you an update of where we are as we look towards the much anticipated launch of this great observatory. We're going to hear from NASA leadership here in the U.S., as well as people on site at the launch site in French Guiana. With us today to offer comments and answer your questions are NASA Administrator Bill Nelson, NASA Deputy Administrator Pam Melroy, NASA's Associate Administrator for Science, Dr. Thomas Sabukin, Amber Strond, who is our Webb Deputy Project Scientist for Communications at NASA's Goddard Space Flight Center, Greg Robinson, Director of the Webb Telescope Program at NASA Headquarters, and Jerome Rivas, Vice President for the Ariane 5 Business Unit of Arianespace. We know the challenges of the launch prevented many of you from attending in person, and there are a lot of you here, so we'll do our best to get to everyone. Please do limit yourself to one question and try to direct it to an individual if possible. If we have time, we might do follow-ups, or after the telethon, we're certainly open to email questions from you. As the operator mentioned, press star 1 to get into the queue for a question. And now we'll start with some opening remarks from our panelists. Senator Nelson.
Hello, everybody. You heard it at the top. The launch is a go for December 24th, the launch readiness review, having just approved it. This is an extraordinary mission. It's a shining example of what we can accomplish when we dream big. We've always known that this project would be a risky endeavor, but of course, when you want a big reward, you have to usually take a big risk. And it's one of the great engineering feats, not just of NASA and our international partners, but also for the people of this planet. This space telescope has been decades in the making. And as with most extraordinary projects that are transformative, there have been some speed bumps, there have been some setbacks along the way. Last week, we worked through technical difficulties with the electrical network connecting the observatory and the ground support equipment. That was down in French Guiana. But the teams are working hard. They were able to identify, they fixed it, and so we're ready to go on Friday. When the telescope launches, it's going to begin a million-mile journey to a point that is neutrally buoyant because of the gravitational forces called Lagrange point 2. And there, Webb will transform our view of the universe. It will deliver world-class science. It's a revolutionary technology that will study every phase of 13.5 billion years of cosmic history. And it will explore that within our own solar system, not only there, but to the most distant observable galaxies in the early universe, to everything in between. So we are expecting to see the light from the first galaxies that formed some 100, 200 million years after the Big Bang, and observe in the process the birth of the stellar systems. So we can look back that far in the infrared and bring it all the way up to the closer in time of our own solar system. And Webb is going to explore distant worlds, and it's going to study the atmospheres of exoplanets. It's going to search as the exoplanet disappears behind that sun or that star, getting the chemical composition of those things in its atmosphere to try to determine what is the habitability of that particular exoplanet. The promise of this is not that we will discover, it's we will discover also what we don't know yet, what we don't understand, or what we can't yet fathom about our universe. And this is the kind of a mission that only NASA and our partners can carry out. It's going to give us a better understanding of our universe and our place in it, who we are, what we are, the search that's eternal. Why are we here? How did we get here? Webb is the keyhole into the past. And it's a groundbreaker for humanity's future. And so I want to turn it over to our Deputy Administrator, Pam Melroy.
Thank you, Administrator Nelson. And I want to say thank you to everyone who's joining us today, because you're going to help us get out the word and generate excitement, because this is a once-in-a-generation event. NASA continues to push the boundaries of what's possible, and this is such an exciting moment. For centuries, humans have looked up at the sky and dreamed of trying to understand the big questions. What was the start of our universe, and is there life out there beyond Earth? Those kind of big ideas, they were what inspired me as a physics and astronomy student, and they're going to inspire the next generation of our scientific leaders. The scientists, engineers, and explorers of tomorrow are opening textbooks today that are going to have a completely new frame of reference based on what Webb shows us. It's as though we have always been living with blinders, unable to see in the wavelengths with the sensitivity to understand our universe. And Webb is going to take the blinders off and show us the formation of the universe. This telescope represents the kind of public good in science and exploration for which our space program was established. And while I talked about the future, it's really important to take a look back in the past and remind ourselves that people like Nancy Grace Roman, who worked to get such an instrument built and launched in a very practical way at NASA and on Capitol Hill in the 60s, her efforts led to Hubble and the start of a NASA astronomy program. For her passion in establishing astronomy at NASA, Nancy Grace Roman is one of the people we thank today. And of course, the future telescope bearing her name will launch later this decade to complement what Webb will do. There is so much amazing about Webb, the intersection where cutting-edge science meets cutting-edge engineering. We had to invent all kinds of technology to make Webb work. 10 innovative and powerful new technologies ranging from optics to detectors to thermal control systems have been developed, which will pay off in benefits in other areas, as so many NASA spinoffs have in the past. We also celebrate the partnership across many nations this mission represents, and you will hear from some of them today. We look forward to the findings from hundreds of universities and institutions in the U.S. and around the world who have already been awarded Webb observing time in its first year of operations. So to everyone who's worked on the mission, you have our thanks. And to our commercial partners who've worked on this, including Northrop Grumman, and Ball Aerospace and many others, we thank you and congratulate you for converting science fiction into science fact. And also for those of you helping to carry the torch of inspiration to today's STEM students. We thank you for that. So I just want to remind everyone that team's work is not stopping on launch day. There's a lot of hard, long weeks ahead where the telescope has to deploy perfectly to begin this amazing work. So stay tuned for updates as we move this observatory out into space. As the administrator said, this is a high risk and a very high payoff program. We've done everything we can think of to make Webb successful, and now we just need to go do it. Thank you. Now I'd like to turn it over to Thomas Zurbuchen to talk about the amazing science this telescope will unleash.
Well, thanks so much, Pam Mallory, and I want to tell you, I love launches. The first launch I actually saw in my life was when I was on this job. I never managed to get to see a launch before, including the launches that the two of the speakers just ahead of me sat on. For me, launches are always the time. It's almost like that butterfly flying away. It's the place where an engineering project turns into a space mission. And as that, and because of its magnitude that the administrator pointed out so well and Deputy Administrator added to it, the James Webb Space Telescope is an Apollo moment for all of NASA, for the entire world, but especially for our science programs worldwide. It's the stuff of dreams. Of course, one of Webb's goals is to study planets that could help shed light on the origin of life as we know it. Dr. Amber Strawn is going to add more to this later on about the exoplanets that are part of our scientific exploration since the mid-90s, where the first exoplanets were discovered and announced. I still remember the day till today, how I felt that day. I knew everything was going to be different. Of course, I didn't think that I would sit here kind of at the beginning of this new phase of exploration of exoplanets that will open up ways to look at these bodies and atmospheres in ways that were not possible to even think about in the mid-90s when that run started. It will help unravel the mysteries of these objects much closer to home, though, as well in our solar system. And I just really want to quickly talk about that. You know, Webb will study neighboring bodies, the surfaces and atmospheres at incredible resolution and spectral range, never seen before. And I want to give you two examples. The first one is Mars, of course, where Webb will be able to see the whole disk of Mars every 2 years or so. By joining forces with other spacecraft, Webb can help us better understand Martian weather and history on its surface, and even whether it may have hosted life in the past. Of course, when we talk about Mars, we always think ahead and think about humans landing there decades from now, really kind of, again, exploring also our presence further out. Webb will help us understand this world. Webb will also study the ocean worlds of Jupiter's moon Europa and learn more about the plumes of water that breach its surface and search for organic signatures such as methanol and others. Frankly, Hubble and Galileo have previously gathered evidence about these jets just right at the detection limit for Hubble, for example. But Webb has real promise to answer these questions about astrobiology, life elsewhere, not only elsewhere in our galaxy, but also right here in our solar system, such as these amazing and bizarre worlds that are Enceladus, Europa, and others. So I'm just so excited about thinking about these, kind of the knowledge about the rich chemistry of these ocean worlds that are out there, that Webb will be part of the discovery. So yes, Webb is at the beginning of a new exciting decade of science for NASA and for all of the international community. It really is James Webb Space Telescope will be at the center of the astrophysics observing program for at least a decade, and will complement missions that are out there. Hubble, the Transiting Exoplanet Survey satellite, which frankly has exceeded expectations in its primary mission, with over 5,000 exoplanet candidates and discoveries, frankly, that we did not expect when we were sending this up there. These targets, of course, are targets that our investigators are looking at going forward. And Deputy Melroy already talked about the Nancy Grace Roman Space Telescope. God, I'm so excited about that too, asking these questions about really the composition of the universe. What's the energy in it? Dark energy, dark matter are topics that come up. Frankly, the time that we're in is almost unprecedented in astrophysics, and what's on that rocket down there in Kourou is really opening doors that are there. Now, I want to just add one more key point, and that is that there are things that we do at NASA that are bigger than our agency, bigger than our country, bigger than our continent. They're worldwide endeavors. One of these questions, of course, relates to the climate here in our home planet, something that we deeply care about with one of the top programs in the world, really focused on understanding this, but also taking that information and making it useful for our own communities and communities around the world. Astrophysics is the same type of topic. This observatory required all the best from government, industrial, academic, and international partners at, frankly, unprecedented proportion. We've never built a space telescope this big and this complex. Frankly, it's the largest international space project in science here in the U.S. history. And as we approach launch, I just really want to take moments to say how proud I am of these incredible teams of thousands who have worked as one on JWST, on the course of its development, and are locking shoulders as they will work together to benefit from the amazing science that we'll produce. These long-lasting partnerships are important to all of us at the agency. They're a personal thing for me, something that I deeply care about, the friends that I've made across the Atlantic or in Canada, working with this, and the many that will work on it worldwide to really look at this amazing universe of ours that have inspired all of us when we were children. I feel like a child yet again as this amazing rocket is set to take flight and deliver this telescope into the heavens above us. I'm really excited now to kick it over to Dr. Amber Strawn, a pilot, a dreamer, a fellow scientist, a NASA Goddard. Amber, take it away.
Amber, you may be muted if you are speaking. We might have some technical difficulties there. Let's move on to Greg Robinson. Greg, we'll come back to Amber.
Well, thank you, Gray, and thanks to all of the media for joining us. We really appreciate your strong interest and continued support as we move closer to launch of Webb. And I'm certainly looking forward to all of the discoveries that Thomas Zabukin just mentioned. So thank you again. I'll just give you a little update on where we came from and where we are. So the observatory arrived in Kourou October 12th. We've had a team down here since mid-September getting ready. They've done an amazing job. They did the post-ship inspections when we arrived, completed our last comprehensive system test where we really ring out the observatory functionally. All was well. As many of you know, we did have a small setback when we were mating the adapter ring to the observatory. The team pulled together and got that resolved pretty quickly with the help of all of our partners. And subsequently, we moved over and mounted on top of the rocket. Just a few days ago, we actually encapsulated the fairing over the observatory, and that's looking really nice. I think many of you saw the pictures, and we're looking forward to moving close to the launch. So we're getting pretty close. As Thomas mentioned, we have an amazing team down here, and the team that got us here. And certainly locally, in addition to our U.S. contractors, certainly want to personally thank ESA down here and BSA in general as a partner. That's ESA here locally, Ariane Sposs and Kness that runs the base here, amazing host. We truly appreciate that. And we had the launch readiness review this morning, and I can tell you the observatory is in good health and ready to go. And so we're going to hear about the launch vehicles in just a minute and the results of the LRR. So with that, I'm going to hand it over to Jerome Rivas. He's the Vice President of Ariane 5 Business Unit. Take it over.
Thank you, Greg, and thank you for your encouragement. So yes, as you said, we had this morning the launch readiness review. This morning and a little bit in the afternoon, it took us some time to review all the data we had between the flight readiness review, which was held at the beginning of the launch campaign, and today. And the result is that after this comprehensive analysis, we concluded that the launch vehicle and the launch system as a whole is ready for the continuation of the operations. This is to say, a transfer from the final assembly building to the launch pad, and then a lift-off 2 days after, in the morning of the 24th of December. So this is the plan we have today, and we are very pleased with all the work that has been made. We had a lot of hurdles to go through since the beginning of this project. We started the preliminary mission design a long time ago. Then we had to adapt the vehicle to JWST specific needs and qualify it. And now we are here on site to execute. And I must say that we are all very excited and looking forward to lifting off this beautiful jewel, which will be a great milestone for humanity. And I've listened carefully to what was said before I spoke, and I must say I'm very impressed by all the breakthroughs that are going to be enabled by JWST. So we're all very, very excited, but very much focused on what we have to do in the coming days to launch JWST to its final destination on Lagrange point L2.
Okay, thank you.
And I'm ready to answer your question.
Appreciate it. Thank you, Jerome. Has Amber been able to join us? I know she was having some technical issues. Okay, we will dive into the Q&A now. As we've mentioned before, press *1 to get in the queue, and we will go from there. The operator will unmute your mic. We're ready to get started, operator.
Thank you. The first question comes from Marcia Dunn. Marcia, from the Associated Press, your line is open.
Thank you. A question, if I might, for Mr. Robinson. You've been in the trenches with Webb as program director. What's your stress level right about now? And could you tell me when is the earliest the sun shield could start to open? How soon after launch, and the same for the mirror? Thank you.
So Marcia, my stress is generally low, and that's the case now. And it actually gets less as we get to the pad until we get into the count, and then it increases exponentially with the rocket. And I'm looking forward to that, by the way. And I forgot the second part of your question. Don't mind.
How soon after launch can you start deployment if everything's going well? What's the very earliest that can begin, and the same for the mirror? Thank you.
If everything is going well, we start that in day 3.
Okay. And our next question comes from Julie Roulette.
Thank you.
Events that occurred between the encapsulation process and now, and also is anybody able to send to reporters, like after this call, some kind of detailed post-launch timeline that shows every expected event from spacecraft separation to L2? Thanks.
Joey, could you repeat the top of your question there? I think it was cut off slightly.
Yeah, sure. For Dr. Zabukin or Mr. Robinson, I was wondering if there have been any anomalies or unexpected events that have occurred during processing since the encapsulation process between now or anything that, you guys didn't expect? And then also after this call, are you guys able to share with reporters a detailed kind of post-launch timeline that shows every event from spacecraft separation to L2? Thanks.
Go for it, quick.
Yeah, so we can certainly share the timeline. That's not a problem. The other question was any working in the anomaly since encapsulation. So we're still working communication issue. I think we put out a statement on that several days ago. It's pretty minor. We can launch with it, but we'll get it resolved as soon as we get to the pad and get powered up. So that's the only one, and don't really expect any issues there.
And what is that communications issue? Is that the same one that NASA talked about before, or is this a new risk that you guys are trying to figure out?
No, it's the same one, and it's not in the flight system on the rocket or the observatory. It's on the ground support equipment.
Okay, thank you for that, Greg. Joey, I did want to point out that at web.nasa.gov, all that information you were referring to about the steps and the deployment and the nominal timeline are there. So let us know if we can help further, but it does exist at web.nasa.gov. Okay, we're ready for our next question.
Next question comes from Lauren Grush. Lauren, your line is open.
Hi, thank you so much. I was wondering if you can tell us what kind of updates we, as the press and the public, should be expecting on all of these deployments. How will that communication be relayed to us over the next couple of weeks? And also, how much flexibility do you have when it comes to doing these deployments? Are they super rigid, or do you have some leeway when it comes to when they're deployed?
So I'll let Gray finish up the answer to the question. But what we plan to put out, you'll be bombarded with updates, you can rest assured. And the team is prepared to do all of that. So we have two time-sensitive events. Of course, after the antenna deploys, the solar array needs to deploy in about 33 minutes, L plus 33. And the other time-sensitive event is mid-course correction burn at about 12 hours. And that'll make sure we're on our right trajectory going to L2. Everything else is flexible, but right now we're certainly planning for a nominal timeline.
Our next question.
Technical difficulties. We're ready for the next.
Next question comes from Jeff Boss. Jeff, your line is open.
Yeah, good afternoon. Two questions. One, just wanted to ask what the weather forecast is for launch, if there any sort of probability of acceptable weather you have in the forecast. And then two, I wanted to circle back to that communications issue, because it was my understanding last week that comms issue that caused the 2-day delay had been resolved, and it sounds like it's still being worked. So if you can provide any more details on what the nature of the problem is and what's still being worked on. Thanks.
So we're just getting some minor telemetry drops that we can live with. We know after we launch and from the pad, everything is S-band. We've run that out many times, and that's working just fine. So no issues once we leave the pad. So just some minor telemetry drops that will not affect us at all. And that's pretty much it. I wanted to tell you it was closed, but I'm going to be 100% transparent here. And on weather, I'll ask Jerome to respond to that one.
We have several briefings for examining the weather, and the first one will be in about an hour now. We are looking to all the criteria for launch regarding the weather forecast. And we have so far one potential concern regarding the high altitude winds, which are very important for public safety issues. So we are going to look at that very accurately in about an hour to address the situation for the 24th of December and see whether we can plan a launch on that date. So far, this is a nominal plan, but we have, of course, to go through this briefing before confirming that the weather should be okay on that day. And what I can tell you is that, of course, this is out of our control, but we are going to examine that point very, very carefully to know whether or not the launch is possible on that day. This is going to happen in about an hour, as I said. At this time, I'm not able to tell you whether the weather is good or not good. And by the way, it's not as simple as that because we have several criteria. And the most important one is the one I told you regarding the high altitude wind.
Okay, thank you. Operator, we're ready for the next.
Thank you. And our next question comes from Irene Klotz. Irene, your line is open.
Thanks very much. I had a follow-up about the deployment timeline for either Thomas or Greg. If for some reason there's an issue with solar array deploy, would it be an option to go ahead and do the MCC-1A burn at 12.5 hours later, or is what would happen in that case? And I know this is an off-nominal, and I know you don't like to speculate, but just so that we have an idea of what to expect if there's some issue with solar array deploy. And then also, what's the backup launch opportunity? Is it on the 25th, or would it move to the 26th? Thanks.
So as far as the solar array, we're certainly expecting nominal performance out of that. Well designed and built and tested multiple times, so not expecting any issues. Just like most spacecraft, you need power, and the solar array is the primary source for that power. So we would have to, I'm not sure if we would do the burn or not in 12 hours, but if we have an issue, presumably we'll get it resolved long before then, since we start deploying about just over 30 minutes after launch.
Obviously you don't plan for anything other than things working perfectly, but I'm not clear if that first burn has to occur at 12.5 hours, or if there's an option to delay that if there's some issue, and also a backup launch date. Thanks.
So when in critical times, you have to do some things quite different. Again, you do need power, so that will become the priority. I'll just leave it at that. And as far as potential dates, Jerome?
Yeah, I don't know whether you refer to what we talked about earlier regarding the weather forecast, but if we have to postpone the launch due to weather forecast on the 24th, the next opportunity is the day after. And as long as we postpone the launch early enough before the fueling of the launch vehicle, we have always an opportunity on the next day. If we do start the fueling of the launch vehicle and there is another issue, in that case, we can postpone the launch to the day after and to 3 days after. But as long as we don't start the fueling of the launch vehicle, we can postpone to the day after, and we have an opportunity every day until the end of 2021.
Thank you.
Okay, thank you.
And our next question comes from Paul. Yes, sir. Next question from Paul Brinkman of UPI. Paul, your line is open.
Hi, thanks very much. I guess for a question for Mr. Robinson, could you just kind of characterize the complexity of this deployment sequence? Is it much more complicated compared to any other spacecraft ever launched, or did you have previous missions to just sort of reference what you may experience with this deployment, or is it just completely unprecedented? Thanks.
I think the administrator and Thomas Dubuque referenced the complexity, like nothing we've done before particularly, I would say, non-human spaceflight. So it's certainly unprecedented, although we often liken it to landing on Mars, the whole EDL, 7 minutes of terror. And I'll invite you to check out 29 Days on the Edge, and it'll give you a little more detail and actual appreciation of how complex it is.
Rex, do you mind if I add to that? So if you look at, there's many different ways of looking at complexity, but one way to look at it is through single point failures that need to work. It's that we've talked about this for years now. If you looked at that metric, landing on Mars takes roughly a third of the single point failures than has roughly a third of the single point failures than deploying the telescope fully. So it really is a level of complexity that's over and above. But needless to say, the parts that are being used, the testing that has occurred, is what gives us the calm. That's why we're sleeping, right? It's because these things have worked, and frankly, kind of rigorous testing has given us the ability to sit here and basically know, hey, we've done the work that it takes for us to get to launch. So that's how I would talk about it.
All right, thank you.
Our next question comes from Marcia Smith of Space Policy Online. Ms. Smith, your line is open.
Thanks so much. I'd like to follow up on some of the earlier questions about how all of you are going to be communicating with us and with the public about what happens over these next 29 days. There was some confusion last week, as to who was speaking for the program. Was it, ESA or NASA or Space Telescope Science Institute? Is there a coordinated strategy, a single place, an authoritative place where we're going to be able to keep track of all of the unfolding of the telescope and the trajectory corrections when you have so many different organizations involved in this?
So why don't I start with this, and I'll go from there. So yes, there's a single point, and that is NASA. We will coordinate with the people involved, and of course, the Space Telescope Science Institute will work with us. They have been deeply connected with us the whole time, as will others, as we get closer to the end of the deployment and then the cool down. Of course, instrument teams that are international will become increasingly important. Our contractors from the beginning, Northrop Grumman, Ball Aerospace, as we or kind of align the mirrors, are going to be really important as well. You pointed out that there's a day where we were not as fast as we should have been, and I just want to tell you, I recognize that. It is true that kind of as we do these complex missions, we're doing our very best to get you the information as fast and as expeditiously as we can. And if in one day we're a little bit slower than we should, rest assured we're taking the lessons from it, frankly, especially as we go forward to this deployment where I know all of us want to know how it's going. So you ask how we're going to communicate, Marcia, and the answer is regularly.
Well, can you tell us what the authoritative website is going to be? Because there's more than one NASA JWST website. So where can we go minute by minute or hour by hour to find out exactly what's happening?
Kicking to Gray.
You can go to nasa.gov/web, I think would be your baseline, Marcia, as well as web.nasa.gov. They should all be in sync. Okay, we are going to take a quick question from social media. Here's kind of an interesting one for a scientist from Twitter. When trying to capture images from back in time, how do we know which direction to point the telescope? Don't know if Thomas or one of our science folks wants to take a crack at that.
Hey, Amber, are you on now?
I'm on. Can you hear me?
Yes, I can hear you now. Why don't you answer? That's what you do for a living. Go ahead, Amber.
Sure. Yeah, so basically we can point the telescope at almost any part of the sky during different times of the year. And if we're trying to look at distant galaxies, I mean, those exist in every direction. And so we have some specific fields that we've looked at, taken deep images with Hubble, like the Hubble Ultra Deep Field. And so those will be some of the places where we look to target those looking back for the very first galaxies, just because we have so much extra data in those parts of the sky.
Thanks, Amber. I think that ties into another question on Twitter. Do we plan on spending time on areas we've already seen, and will we be able to see better details of those already viewed areas?
Yeah, so the Hubble Ultra Deep Field is a great example of that. So with the Hubble images of these very deep fields, we've been able to see some very, very distant galaxies. But we know that the furthest ones we've detected with Hubble was off the first galaxies. And of course, this was one of the primary goals of Webb way back in the early days, was to be able to find those first epoch of galaxies. So absolutely, we'll be looking at some of those well-studied deep fields. We'll be looking also, of course, at nearby exoplanets that we know are in their habitable zones. So examples of that would be the TRAPPIST system of exoplanets. And those observations are already scheduled or planned for the first year. So we'll be doing a lot of that, and then of course we'll also discover new things and look at new things along the way.
And of course, Amber, one of the things that's really exciting me is actually the stuff we don't know yet, right? We're looking at the sky in an entirely new way, and one of the things we do is we plan to read the science program every year. So what will happen, kind of year 2 and 3, as we go forward, year 4, we'll include the learnings from year 1 and year 2 and so forth and so forth. And kind of the more we go, I'm sure we're going to look at many different places that right now we wouldn't even know that they're the most exciting places to look at. So kind of the element of surprise is something you can count on when you build a new telescope or entirely new capability, right, Amber?
Absolutely, and for me as a scientist, so I study distant galaxies, and so I'm very, very much looking forward to what we'll be able to do in that field. But as a scientist in general, I think the most exciting prospect of a telescope like this is that element of surprise, the fact that we'll discover answers to questions we haven't even thought to ask yet. And that happens every time we launch a big, bold telescope into space, and this is the biggest and boldest yet.
Okay, thank you. Operator, we're ready for the next question in the queue.
Next question comes from Stephen Clark of Spaceflight Now. Sorry about that. Stephen, your line is open.
Hi, Stephen Clark from Spaceflight Now. Thank you. First of all, I did want to echo a request from, I think, Joey early on about the timeline. I have seen the timeline on the website, but it's sort of in broad strokes, like a day-by-day generalized timeline. I was wondering if there might be something more specific, like minute-by-minute, hour-by-hour timeline available. I know you have that internally. I was wondering if you could release that to us so we know when things are nominally supposed to happen on each day instead of generally day-by-day. And secondly, my question also maybe for Jerome, I know the Ariane 5 has cameras on board looking up toward Webb at separation. Can you talk about whether we will see those camera views live during separation, or is that view going to be recorded and replayed to the public later? Thank you.
Yes, we have 2 cameras on board, which are aiming at James Webb, and which will shoot the separation of Webb from the launch vehicle. And the plan is to have the transmission of the video footage almost in real time. There will be a span of a few seconds between the arrival of the images and their emission on the video transmission that will be public. But the plan is indeed to have these images almost in real time to witness the separation of James Webb while it's going to the Lagrange point. Before we definitely don't have the spacecraft on site.
Okay, thank you, Jerome. We are getting close to the end of our time, so if you do have a question, please put it in the queue now for with *1, and we're ready for our next question, operator.
Thank you. Our next question comes from Marina Corn of The Atlantic. Marina, your line is open.
Hi, everyone. A question for Greg, I think, about the communications issue. You said the issue hasn't been fully resolved. Can you say a bit more about what makes you and the rest of the team confident that it won't affect the launch? And are there any other elements that you've encountered in the last few weeks that are of a similar nature, you know, not ideal, but something that you're willing to accept and move forward with the launch?
No, that's the only issue that we've been working. Again, it's just some minor dropouts, telemetry, which is not a problem. We've tested in many configurations, and every time we've tested our full comm system test, RF testing, et cetera, everything has worked flawlessly. So we have no concerns with the flight system on either side.
And this is Amber. Just to jump back in quickly on the previous question about where you can go to find the deployment details. So very soon, before launch, we're planning to release a new function on the web.nasa.gov website that will show the current deployment state of the observatory. And so that will be a place to get that information. There will also be daily blogs on blogs.nasa.gov/web that will give, the first couple of weeks, there'll be daily blogs that will give updates on what's going on. It's really important, I think, to recall that our deployment, the whole deployment process is very much human controlled. You know, with the Mars missions, you have to hit go and then everything happens, the landing happens as an automatic sort of procedure. With the exception of the first couple of deployments right after spacecraft separation, all of our deployments are human controlled, do them one at a time, make sure things are working correctly on that. So the nominal that we've all animated, that very what happen in the exact timing that is shown. So there's a lot of flexibility built into that deployment sequence on purpose.
Okay, thank you for that, Amber. We are almost out of time. I'm going to take another question from social media. I think probably any of our panelists could answer it, but Amber, maybe you want to take a crack at it. What were some of the major challenges in designing this observatory?
Well, yeah, I think almost anyone on this panel could probably talk about that. But for me, it seems that the two biggest challenges that drove all of the engineering design was the fact that the telescope needed to be so big and the fact that it needed to be cold. And of course, it needs to be cold because it's an infrared telescope, but designing a huge telescope that has to operate in space in deep cold was and is an extremely challenging engineering scenario, and that drove all of the engineering design.
All right. That is about all the time we have now. Appreciate the time of all of our panelists. Thank you for your insights. We're looking forward to Webb's launch very soon. There will be an instant replay of this telecon available for a month, and it will be up in probably about an hour. If you want to dial into that, the number is 866-359-6499. I will repeat that. It's 866-359-6499, so you can hear a complete replay of this. And please also feel free to contact all of us in the comms office for any further questions you have about Webb. And that will conclude our call today. Go JWST. Thanks.
Thank you all for participating. You may now disconnect. Speakers, please stand by.